Hello, welcome on in. My name is Nate, and today we're going to be working through unit conversions. Not necessarily dimensional analysis, we're going to be doing that in another video. Just simple unit conversions and just how to make them a lot easier so that you never miss questions about unit conversions. So the main idea behind how we're going to be doing unit conversions is just cross multiplication. Pretty simple. This will be a really quick video, but basically let's just say that you are trying to convert. Let's just say you have 3 atmospheres, but the question wants it in pascals. So how do we convert that? Well, the conversion is that every 1 atmosphere takes up about 100 kilopascals. That's rounding. It's 101.4 technically kilopascals, but we're rounding. On the MCAT, you can round. That's a very small rounding error. That's only a 1% out rounding error, so you're fine around this. So 1 atmosphere takes about 100 kilopascals. So obviously in this example, you're probably quickly thinking like, oh, I just multiply this number by 3 to get the total kilopascals. But if you don't see that, basically what we can do is just set up a cross multiplication scenario, right? So we're going to put atmospheres on the top, right? We have 1 atmosphere is the same thing as 100 kilopascals. This is basically like the theoretical, I guess you could say. And in the actual scenario, we have 3 atmospheres. And we're trying to figure out how many pascals that takes up. We'll just make it easier. We'll say kilopascals. But so all you have to do from here is cross multiply. So this simplifies to 1 atmosphere times x kilopascals is equal to 3 atmospheres times 100 kilopascals. And basically this is just going to simplify to whenever you solve for x, you're just simply going to get that x is equal to 300 kilopascals. Right, just to show you the expanded form of that, we'd be dividing both sides by atmospheres. So we would be left with, the atmospheres would be canceling out, and we'd be left with 300 kilopascals, just if you wanted to see the units on that. But basically, that's how we're doing unit conversions. That's how I recommend doing it, just a simple cross multiplication, right? So now we're going to do a little bit more difficult of conversions. This first one that we're going to do, we're going to take kilopascals. Let's just say that we're trying to go from 50 kilopascals to an X amount of millimeters of mercury, which is the same thing as torr. I'll write that in parentheses, or torr. They're the same thing, but so we're basically converting kilopascals to millimeters of mercury, right? The pressure conversions are one of the more common ones that you would see. Realistically, these aren't too common. The most common one that you'd see is atmospheres to pascals, because fluid dynamics and fluid statics is going to be using pascals instead of atmospheres, where pretty much the rest of everything is going to be using atmospheres. But they might give you a conversion. It's more common that they would give you some weird conversion that maybe you're not necessarily used to or you don't know. And this is basically what I'm doing, that you can just quickly plug them into a cross multiplication setup and you're going to be fine, right? So the typical conversion is that 1 atmosphere is equal to 100 kilopascal, again rounded, which is equal to 760 millimeters of mercury. Right, so this is the conversion that we're going to be looking at. We can just set up that same cross multiplication. 100 kilopascals over 760 millimeters of mercury is equal to, I give you 50 kilopascals all over 700, an X number of millimeters of mercury, and that's what we're trying to solve for. So then we just cross multiply. We basically get X millimeters of mercury times 100 kilopascals. That's going to be equal to 50 kilopascals times 760 millimeters of mercury. So we're going to divide both sides by 100 kilopascals, which is going to get this to cancel out over here. That's also going to get the unit kilopascals to cancel out. So we essentially can simplify this, that we're doing 50 divided by 100, which is going to be 1/2. So basically we have 1/2 times 760 millimeters of mercury. So we're basically just dividing 760 by 2. Let me slide this over really quickly. Which is roughly, you can estimate this as much as you want, but it's basically going to be about 380 millimeters of mercury. Right? Your answer is just going to be right around there. It's going to be pretty easy to pick them out. So we'll do one final conversion that, as you can see, just as long as you can set up cross multiplication perfectly fine, these unit conversions are going to be really easy. But we're going to do one final question that, let's just say that they give you that there's a photon that has an energy of 3.2 times 10 to the negative 19th joules. And it's possible that maybe instead of just asking you to solve for the wavelength or something, maybe they might ask you to solve for the number of electrons that are composed in this amount of energy, which the way that you would need to do that is convert it to electron volts. So they might give you this conversion. This is one that I memorized because I wasn't quite sure if they were going to give it, but I basically 1 electron volt is equal to 1.6 times 10 to the negative 19th joules. So basically from here, we can just do the exact same thing. We're trying to get 2 electron volts. And so because of that, we can just set up the cross multiplication. It doesn't matter which is on top or on bottom, just as long as it's the same on both sides. 1 electron volt over 1.6 times 10 to the negative 19th joules is equal to an X number of electron volts over 3.2 times 10 to the negative 19th joules. Right? We have the conversion on the left side and the actual, what I was actually giving you and what you're solving for on the right side. So because of this, we can basically just cross multiply now at this point. We have 1 electron volt times 3.2 times 10 to the negative 19th joules is equal to an X number of electron volts times 1.6 times 10 to the negative 19th joules. We're going to divide both sides by 1.6 just so we can solve for X. So this is all going to cancel out over here. The joules is going to cancel out, and we're going to be left with electron volts. So we're basically going to end up with 3.2 times 10 to the negative 19th divided by 1.6 times 10 to the negative 19th. We're left with electron volts at this point is equal to an X number of electron volts. Simplifying this is just going to simplify to 2. And 10 to the power of 19th minus 10 to the negative 19th is just going to give us 10 to the 0th power. If you know exponent rules, basically if we're dividing, we subtract the exponents. So negative 19 minus negative 19 is going to give us 0. And this is just equal to 2 electron volts. So from there, like if they gave you the voltage, you could go through and solve for how many electrons would comprise that those 2 electron volts. But basically that's it. That's all you need to do for unit conversions. Just set up cross multiplication where on one side you have the conversion and on the other side you have what you were given in order to actually solve for whatever new value you're looking for. So that's it. In my math and equations course, we're going to be doing a lot of practice with this. This is also a really important skill to kind of start understanding this idea of crossing out units, because the next thing that we're going to do after this is dimensional analysis, which is where, like, if you're given grams, how do you get to concentration or something like that? And that's going to be a really, really important skill for the MCAT. And so if you can kind of start to see this pattern of canceling out units, that's going to make your life significantly easier. But this is my recommendation for how to just quickly do unit conversions on the MCAT. It's really easy, really simple and straightforward. If you want a ton of practice, we'll have it in the math and equations workshop. You can sign up for updates on that at the link in the description if you're not already watching that video through the course right now.